Hello friends, so welcome back to the tutorial series of object-oriented programming in PLC. So today we will be learning about abstraction and inheritance. So till now we have covered the classes, encapsulation, how it was getting used in the PLC, how we can incorporate inheritance into the PLC of the CoDeSys. So let's go about the next pillar of the object-oriented programming, which is abstraction. So before going into directly into implementation, let's understand what exactly abstraction means. Okay, so abstraction, if we go by a literal definition of dictionary meaning, then it is meaning something pulled or drawn away. Okay, but if we go with the meaning of how it is defined in the programming language, so it is like something which is not concrete. Okay, so or we can say that it is a state of mind where we go into daydreaming, like we think that after learning object oriented programming we can directly implement and everything by using oops concept. So till now we have not reached there, but we are daydreaming, correct, that we will be able to do everything and we will be completing everything by using this. So that is called basically abstraction. Okay, so what is the main goal of this abstraction? So why we need to use this abstraction into our core philosophy? So basically it is utilized to hide the unnecessary details from the user. Okay, so something which are not relevant to the user, they don't need to understand. Okay, and they can build on top of it only the required items which is needed for them. So basically it reduces the complexity of the development of the program. So that is how we can see abstraction as. So when we do this abstraction layer in our project, basically, so if we see this abstraction concept, we do mostly at design level when we are designing our project or we are planning our project. Okay, so this abstraction layer comes mostly at that particular time. So for example, we have the sensors, correct? So sensors actually has a lot of features. Okay, do we need to know all the features of the sensor, or because sensor is implementing a lot of things? So but when we read the data from the sensor, what we read only the 4 to 20 milliampere. So what it is sensing, and after converting the process value into electronic signals, it is sending it up to us, correct? So that is what exactly we will also do in the programming part. So when we create the layer of abstraction in the program, so we hide the things which are not needed for the user to know, and we only provide them the things which make them easier, or make their reduce the complexity of the program. Okay, so for example the scaling part. So if we see here, the example which I have given is the FBS sensor scaling. So scaling is something they don't need to know how exactly the scaling is getting done. Okay, so what they will use the FBS sensor block, they will use the scaling block and just provide the input and output. So hiding the data is also something we used to do in the encapsulation, correct? But that I will talk it further, but let's understand first how exactly this abstraction is implemented. So in order to implement abstraction, it is getting done by using abstract class and the interface. So abstract class is nothing but it is just an idea or the thought which doesn't have the concrete existence. And what is the interface? So interface, as the name is suggesting, it is a point of interaction. So where we do a contract basically to start any talk or start any project. So without that contract, we cannot move ahead. So that is how the interface we can treat it. So interface, we use something called implements. So if you see the name as implement, means we have done a contract, which means we have to implement those contract. in our project. But abstract class, how we use is extends. So if you remember extends, how, where it was getting used, it was getting used in the inheritance, correct? So means we inherit or we extends the methods and property of the abstract class and say to get utilized. Okay, but one thing, the difference between a normal class and abstract class is that abstract class objects cannot be created. Okay, so objects or the instance cannot be created. So that is a very basic difference between abstract class and the normal class. So the function block we use. So let's go and see how exactly we implement these things in the CoDeSys. So we need to right click and go to add object, and we have to click on the interface. So we will get a pop-up where we will fill the name of the interface which we want to create, and then we can click on the add. So a interface object will get added. Okay, so if you see in the interface, we don't have anything here, only the blank. So that is how it get created. So let's again go to add object and then click and give a name and select function block as abstract. So this will be creating a abstract class. So we can define whether access modifier everything. So click on the add. So it will add the abstract class. Now in the abstract class, you see the structure remains as it is, as it was earlier, but the name will come as an abstract. Okay, so as definition says, we can extend and we can implement. Okay, so let's try it out how exactly it's go. Okay, so let me go to application, click on the add object. We will create another function block as PI101, and we will say extends. Extends to what? Extends to my abstract class. Okay, so if you see, it will say, and click on the add. So I will remove that it is not an abstract now again. So okay, so now if you see, it says the PI101 extends the abstract class, correct? So if I give here some details like input, a variable I define, so all those things, if I go to the PI101, so super we use to when we do any inheritance part, so we use super. Now if you see, it is getting called, so we are able to access the variables also of the abstract class directly here, correct? So as we do, but if we define anything in the var, which is a local variable, of course that we cannot access. So only for the var input, var output, var inout variables only we can access. Rest local variable which is defined in the var, that we cannot. So let's create another function block and say implements. So implement is what? Is interface. So I'm using interface and I'm saying okay. So here if you see, it says TI101 implements the interface. So another way is if when we click on the implement interface, unable to find any methods there, so it is not able to implement it. So another way is to write directly in this and implements and give the interface name. So now what is happening is the function block PI101 is extending to abstract class and implementing the interface. So if you see here, it is getting into kind of multiple inheritance, correct? So I'm able to inherit from two different objects. So let's create the instance of first PI101 and TI101. So if you see, we cannot create the instance of the abstract class, but we need to extend that abstract class to another function block, and then we can create the instance. So that is, so I think that particular feature is also working fine. So now let's create a method for the interface. So I created a method called a scaling. So if you see, it is an it is not implemented, only we can define it here. So it is like anyone who is accessing this interface has to implement it. So that is why we got this error on the bottom. Okay, so let's see. So that is what it says, that it interface can have only abstract methods. So which abstract method means it has to get implemented. So interface cannot provide the implementation of the abstract class. So it cannot provide the implementation, but it only say that yeah, it has to get implemented. So when we click on implement interface, those methods will be getting shown in the function block as a method. Now if we compile, we will only get the warning that these methods are not implemented, but that is fine, because that is how the pragmas are defined for this method when we implement any interfaces. So that we should be cautious and we should go and implement what we want. Okay, so let's create a methods in the abstract class also. So it is, first we will create a method which is not abstract method. Okay, so method 1 scaling, let's create and return type as a real. So let me define the name. Okay, so this particular method is created. So now if it is not an abstract method, correct, so when we compile, it will not give me any error. Okay, and if we even click on implement interface or anything, these methods are not going to come directly here, because that is not an abstract method. So let me just provide some detail so it will be easier to understand. So scaling as it is, so I will define the same logic here. Okay, let's compile it. No error. Now let's go to the main and let's see with the instance of pi101. Okay, so if you see, we are able to get the those methods, one of the interface and another one of abstract class, both directly, correct. So abstract class, we have not called anything, but we have extended. So the parents methods are getting inherited, and we can directly utilize that. So wherever, for example, we have created one abstract class and we have multiple places where we have to use a scaling, so only one time we have defined, correct, and we can utilize it at every places by extending it, so inheriting the abstract classes. So that is what exactly abstract class tells, correct. So here if you see, we are getting the error that method scaling needed to all three inputs, because we have defined var input, the three different inputs are there. So those things we have to define, that is a basic of our function block programming when we do. So it is not anything different other than that. But yeah, I wanted to show that how exactly the error is getting created and what we have to do to correct it. Let's create another method for the abstract class, because we have gone through, correct. So we will create this one as an abstract, and we can define the access modifier, but let's leave it like that. Now we have defined. So if you see here, we cannot implement anything for this method here, but when we compile, it says that it is not getting implemented in the function block where it is extended. So this is how we exactly add the methods and implement it. Now if we compile, okay, so uh, still we get some error, correct. So okay, so this is the issue. Let's compile again. Yeah, we are getting the error and it is saying that it is not matching with the declaration. So if you see here, our declaration is only var input and var, but here we are defining a lot of things. Okay, so now even if I have to remove and let's put other things in the var input, still we are getting, because these in the var input of the abstract method, there is nothing, it is empty, correct. So what we have to do is we have to maintain the same structure how exactly it is defined in the abstract methods. Okay, so And in the abstract methods, or we cannot define any of the local variables. So var we cannot define, so that is why we are getting those kind of error also. So we have to very cautious when we are defining. So it will accept only var input, var output, and var in out, no other things. Okay, so this is the very basics. So even in the interface we cannot define the local variable, we will only able to define var. Now when we do the changes, the same thing is needed and asked in the all the interface where it is getting implemented. Okay. Okay, so even if I have implemented this method, still the warning is not going correct. So if you see, what we need to do is we just need to remove the pragmas what was defined. So in order to remove this warning, because that pragmas which is mentioned on top is a kind of a warning pragmas only. So till those are mentioned, it will keep giving the warnings. Okay. So let's now see. So we have defined and done the implementation of the scaling of the interface. Let's write the code in the main, and let's see after building it. So no error, no warnings of that, and everything is working as expected. So that is how the interface has all the methods of the interface has to be also implemented, and it has to be done. So now let's create another block. So how exactly we can utilize this interface and implement in the different way. So I have created another function block which is implementing the interface and its method scaling. So let's go and define in the scaling part. Okay, so let me copy paste all the input output, and let's now copy paste the logic. So now as this is AO, so it is analog output, so and TI and PI were analog input. So I will just swap the ROM in ROM X to get the just opposite of the input scaling, and now it will be doing for the scaling output. So if you see, the same interface I have used, the same methods I have used, but I am using it in a two different ways, because it is on my own correct in what way I want to implement it. So these are very helpful when we are defining a library, or when we are doing the initially the planning and designing level, correct. So we define the structure, that this is how exactly the user has to develop, or the developer has to develop the code, and they have to, when they will use, they have to implement these contracts or these interfaces into their program, but they have the free hand that how they want to implement it. So whether they want to use for analog input or analog output. So those things are very handy when we use this OOPS concept and all those things. So let's see here. So we have defined everything. It is giving no compilation error. So let's download this in the emulator, and let's try it out how exactly it is behaving. So whether it is running correctly or not even. So let me download, and once it is getting download, we will go to the run mode. Yeah, so let's go and check out by putting some values, and let's see how exactly it behaves. So okay, let me change some of the variable names so it will be easy to understand. Okay, so let's change the values, and if you see for the input, when I gave for the analog scaling input, it is giving me another the output is having 1, and for analog output the output was different, correct. So let me comment out. So we will only focus on these three instances. So let me download again. Okay, so if you see, yeah, the analog output is different than the PI101 output, correct. So This is how exactly it so it is working fine. So for analog output we have a different implementation, for PI 101 and TI 101 we have a different implementation. So that is how exactly it is working, so based on the implementation part. So if we keep changing the values, yeah, so it will behave in a similar manner for what it has been implemented. And if you see, we are not exposing here any of the other details, only the values or the parameter which are defined uh, in that particular blocks. So nothing we are exposing of the abstract classes. So if you see here, correct. So yeah, so here also it is just the two variable, nothing about the implementation. So that's what exactly this abstraction layer is doing. So that is how we can utilize this particular feature into our PLC code. So I'll go in more detail on this. So let me so if we go by all the differences and definitions, so most of the things are possible in the CoDeSys PLC. And only one thing which I was not able to find is the when we define any variables in the interfaces, those are finals. But I think that is not happening because we are not able to define any directly the variables into the interface because that is not supported, and we have to only define the properties and the methods. Okay. So yeah, means most of the things are covered. So let's get it compared also how exactly it is done in the IT. So let me show you some example. So if I go to, so this is a basic program I've created with the same structure. So if you see, this is abstract class which is defined for analog sensor. This is the normal function block or class basically. And here I'm doing a class which is getting extended with the abstract class and implementing the interface, and this is the interface. So if you see here, we are able to define the variables, but same thing we cannot define that in our PLC code. So that is how exactly this structure is, and this is how exactly it works. So even if you see in the Java or .NET and any IT programming language, it works similar way. So we override it here, we implement. So when the methods, and then we create the instance and call it in the main program. So and when we run the code, it will give the values whatever it has to generate. So one thing which I told that I will tell you how exactly it is different from encapsulation. So basically the difference between encapsulation and abstraction is, in the abstraction we implement everything using abstract classes and interfaces, whereas in encapsulation we do it using access modifier like private, public, protected. So all those things we use. And another major difference is uh, in abstraction we do everything at a design and planning level, correct. So but encapsulation, where it comes, it solves all these issues when we are at implementation level. So uh, we use then getter setter methods to hide the data, and in abstraction it is everything is done using abstract classes and interfaces. So that is how exactly these two are very different. So yeah, that's all for this particular video. I will be covering more details in the next coming chapter, and about abstract class interface and how we can start any project, and how exactly we can build a basic template. And also we'll be covering about the another concept or the pillar of the object oriented programming, which is polymorphism, and also give you the context why actually we now need to move towards object oriented programming, because there's a new standard coming in the OT world, which is coming as a module type package MTP, which is started by the Namur. So stay tuned for the next videos, and see you soon. Thanks for watching. That's all for this video. See you in the next one.